When children are in the process of learning a new language, we can notice how they move their hands around while they talk and sometimes even just use gestures to help explain what they are trying to say when they don't recall the words. This simultaneous use of gestures in speech is known as code-speech gestures. Our study is designed to combine the fields of computer science, linguistics, and psychology in order to observe how code-speech gestures, when used by AI robots to teach a new language, helps learning. Our main aim would be to determine if learning a second language from a robot that uses code-speech gestures is as efficient as learning the same language from a second language teacher. There have been many experiments that have provided ample evidence to show that code-speech gestures do play a significant role in learning and memory retention, along with studies showing that code-speech gestures used by robots helps engage listeners. The results in our study will be acquired by assessing the participants' memory retention throughout the course. This study would help in the process of using technology to optimize language learning. Professors teaching first and second year language courses can benefit from this by getting more time to conduct their research. This experiment would be the first step to obtain a proof of concept, and by further experimentation and changes in the technology, we can ultimately maximize the efficiency of learning.
For this study, there will be a testing phase before the actual experiment with participants. Our humanoid robot Pepper will be taught a self-developed algorithm in order to execute similar code-speech gestures to humans. Participants in the experiment will be randomly assigned to 3 treatment groups: Pepper teaching with code-speech gestures, Pepper teaching without code-speech gestures, and a human teacher teaching. Groups with Pepper will act as experimental groups, and the group with the human teacher will be the control group. As it is natural for humans to converse with gestures, the control group will not be specifically assigned to incorporating code-speech gestures. Participants will be organized in such a way that only the torso of Pepper with the human teacher is visible. As code-speech gestures are seen from the hand and arm movements, this is to minimize other possible distractions. 12 arbitrarily chosen words in Japanese will be taught in each group with word meanings given twice. Each group will have 3 training sessions, all separated by a short break. The order of the words will be randomized between each training session. A recall test in the form of multiple choice questions will be given to each participant to assess their ability in recalling the vocabulary. If a higher number of words remembered correctly in the treatment groups with code-speech gestures is observed, then this demonstrates the importance of these gestures in short-term memory retention and understanding of a new language.
Our evaluation has 2 checkpoints. The first is after training Pepper on our self-generated dataset of Japanese teachers teaching second language learners. We will have a comparison study between human gestures, Pepper's proposed gestures, random gestures, and 2 other conditions. Before proceeding, we require results showing that Pepper is ranked significantly higher than the other conditions, and similarly to humans on evaluations of lifelikeness, likability, and speech gesture correlation. After verifying that Pepper's training is adequate, we will test the effectiveness of this training on real teaching. Here we hope to see that participants remember a higher proportion of words when taught by Pepper with code-speech gestures over without. Also, we hope to see that Pepper and the human teacher show no significant differences in effectiveness of teaching, laying the groundwork for the first step towards the independence of robot teachers. Through combining the efforts of previous studies, we hope to show that code-speech gestures could be key to the development of language teaching programs with a robot solely in command.
In conclusion, this experiment is a foundation for widespread experiments that can be done to prove that robots like Pepper, now mostly known as teaching assistants all over the world, can be equally good teachers if trained well. This idea of robots becoming equally good teachers would provide professors and institutions the opportunity to pay attention to their research and other side projects. This is very important in today's day and age where education is becoming more home based and alternative interactions are continuously being sought for learning. Adapted from Youngwoo Yoon's research, our experiment uses a very simple training model that takes vocabularies attached to relevant code-speech gesture as a dataset and teaches this dataset to teach Pepper how to react to every word in a language and provide code-speech gestures to it using a neural network. Although our experiment is very limited in ways that it only works with semi-humanoid robots like Pepper, and it only works with language learning, we believe that we have combined neuroscience, computer science, and linguistics to successfully pave the way for novel experiments in human-computer interaction, social robots, second language learning methods, as well as influence of co-speech gesture. Thank you.